Hello everyone. We are discussing rolling. And so far we have developed this concept. If center of mass of the wheel is moving with V and this wheel is rotating with omega, angular velocity is omega. If V is equal to r omega, then velocity of the contact point becomes zero. This is the contact point. Its velocity becomes what? Zero. Center of mass moves with V, and the highest point it moves with 2V. This is something which we did in the previous lecture. If V is r omega, this is called pure rolling. Pure rolling means velocity without slipping. Contact point, its velocity is what? Zero. Now, in this situation, if I say that this is a rough surface, this is a rough surface, coefficient of friction is mu. Then, for the wheel which you see in the figure, moving in this direction, what is the direction of friction at the contact point? Listen again. You have a wheel, and what you did? You gave this wheel a velocity v in the forward direction. At the same time, you gave it what? An angular velocity omega, such that v is r omega, which is called pure rolling. Velocity of the contact point becomes zero. What is the direction of friction at the contact point if the whole thing is placed on a rough horizontal surface? Think about it. I'm giving you 20 seconds to figure out this. Only one response. Look, the response which I got is this, that friction will act in the forward direction. Suppose this is the case that friction acts in the forward direction. Let's investigate this scenario. Now, this is your axis of rotation, remember, which is passing from the center of mass. This is the axle of the wheel. V is this velocity of the center of mass. If friction acts in this direction, then it means what? You have a force in the direction of velocity of the center of mass. When we write F equals to ma, remember A is acceleration of center of mass. So, on this disc, wheel, sphere, or anything which can roll, you have a forward force. The other forces are what? mg, which is acting downward, a normal reaction which is acting up. In the horizontal direction, you only have one force, which is what? Force of friction. This force of friction is acting in the forward direction, which means from this, if you have a force, then this force is going to produce what? Acceleration. Whose acceleration? Of the center of mass. This center of mass, therefore, because of this force, is going to accelerate. That means V is going to increase. फिर से सुनना, अगर ये फोर्स आगे लगता तो ये फोर्स क्या करेगा? इस बॉडी की जो सेंटर ऑफ मास की वेलोसिटी है उसको क्या करता? इंक्रीज. Now, about this axis, if this is the direction of force, then what is the direction of torque? Axis, force. This force is going to produce a torque like this. This will be the torque of friction. This torque of friction, and look at the direction of omega. Look at the direction of torque of friction and look at the direction of omega. You can see that omega is being opposed by the torque. So that tells us that in this situation, omega is going to decrease. मतलब क्या? अगर फोर्स ऑफ फ्रिक्शन ऐसा होता तो जो टायर है, जो व्हील है, उसकी स्पीड तो क्या होती? इंक्रीज, लेकिन उसकी एंगुलर वेलोसिटी क्या हो जाती? डिक्रीज. Remember, I told you in the previous lecture that whenever things roll in normal situation, whenever things roll, then in normal situation it's always pure rolling, unless you apply some external force or you create a situation where things start slipping. In normal situation, your bike, your bicycle, they are always in the pure rolling mode. अगर ये अपने को पता है कि हमारी बाइक का जो नॉर्मल सिनेरियो है वो प्योर रोलिंग वाला है और फ्रिक्शन अगर आगे लगता तो क्या सिचुएशन बनती? टायर्स की स्पीड तो बढ़ती लेकिन उनका ओमेगा क्या हो जाता? डिक्रीज ना. क्या आपने कभी ऐसा होता देखा है कि एक टायर, उसकी स्पीड बढ़ रही है लेकिन उसकी रोटेशनल स्पीड कम होती जा रही है? नो. नॉर्मल सिचुएशन दिस डजंट हैपन, which means if you have a wheel which is in pure rolling, you cannot have friction in the forward direction because it will create a situation where speed is increasing continuously but angular speed is decreasing. That means after some time what will happen? That this omega decreases and becomes zero. So you have a scenario where wheel is moving forward and it doesn't have any rotational motion, something which is not possible. So a situation like this is not acceptable. So if friction is not acting in the forward direction, maybe it's acting in the backward direction. If you have force of friction acting in the backward direction like this, जो भी हमारा आर्ग्यूमेंट था उसमें केवल क्या होने वाला है, V is in the forward direction, this is your omega, but this time you can see that V is being opposed by friction. That means इस situation में V क्या होता, decrease. Force speed को क्या करेगा, decrease. It's a retarding force. And what about direction of torque? Friction acting like this is going to produce a torque like this. This is the torque of friction. Torque of friction. And you can see that this torque is supporting omega. They have same sense of rotation. Clock. That means omega is going to increase. Which is what? Let's take the same wheel. जब आपने इसे प्योर रोलिंग मोड में रिलीज किया, अगर फ्रिक्शन पीछे लगता तो उसका जो V है वो तो क्या होने लगता, डिक्रीज, और उसकी जो एंगुलर वेलोसिटी है वो क्या होने लगती, इंक्रीज. But is it possible that your wheel has after a certain time stopped moving forward and is rotating at the same place? It has increased its angular velocity, but it has stopped moving. Again, this is something which is not possible in normal scenario. Which tells us what? Pure rolling on a horizontal surface, even if surface is rough, there will be no friction at the contact point. Now, कुछ लोग क्या सोचते हैं, बॉडी आगे जा रही है, and therefore some of you will say that friction is in the forward direction. Friction का लॉजिक था कि बॉडी आगे जा रही है, there must be some force. Well, we are not accelerating the body. We left the wheel in pure rolling mode. This V is something which you gave it. You gave certain velocity and then angular velocity also, and now you put the wheel on a rough horizontal surface. It starts doing what? Pure rolling. In this scenario, ये जो V का पार्ट है और ओमेगा का पार्ट है, ये अपने को क्या बताता है कि अगर फ्रिक्शन आगे और पीछे लगेंगे तो वो इस तरह की एब्सर्ड सिचुएशन क्रिएट करेंगे, something which is not possible, and therefore friction is completely zero. अब कुछ लोग क्या बोलेंगे कि सर बड़ा इजी था इसको याद रखना, फ्रिक्शन इज जीरो, हाउ कैन वी रिमेंबर इट? कुछ लोगों का दिमाग ये चलेगा, सर कांटेक्ट पॉइंट की वेलोसिटी क्या है, जीरो, so this contact point is not moving and therefore friction is zero. We'll see later that even if contact point is not moving, we can have cases where friction is present during pure rolling. Not in this case, देखेंगे बाद में. अभी के लिए this whole thing is a one line statement. During pure rolling, do one thing, note down this figure and everything, and then we'll write this statement. And if you understand 70-80% this concept, this is rolling, and by the end of the today's class you will understand everything clearly. But as of now, if you are comfortable with at least 70-80%, then write down yes in the comment box. If you are not, do not hesitate, write down no. Good. Some of you are saying yes and some of you are saying no. Those who are saying no, just don't worry. And it's a good thing that you are giving your own honest opinion. Write down the statement. During pure rolling on a horizontal rough surface, on a horizontal rough surface, in the absence of other external forces, in the absence of other external forces, friction at the contact point is zero. Remember, surface is rough, but it is offering no friction. Now, let me explain this part. So this is a wheel or anything which can roll basically. It can be ring, disc, cylinder, solid, hollow, sphere, anything which can roll. This is rough, horizontal surface is rough. I said in the absence of an external force. If somebody starts pushing the ball, then friction will appear in this setup. If you start pushing the ball, if you attach a rope and you pull the whole thing, or you simply, with any type of force, you blow air into it so that it starts moving, immediately friction will reappear. But if you have a ball, you release it such that it is pure rolling. You gave it V and omega and you release it on the rough surface. It will keep on moving for, look at this, V, and the only horizontal force Fr is 0, which tells us what? Downward force is what? Mg. Normal reaction is up. There is no contribution of mg and normal reaction in the horizontal direction. इनका कोई contribution नहीं है. कोई भी force, कोई भी vector अपने से 90 पर कितना contribute करता है? 0. And the only thing which we expected in the horizontal direction, that is also not present. Fr is 0. Which tells us what? This V is not going to change. If force is 0, force of friction, its torque is also 0. And mg and normal reaction, they're not going to produce any torque. Why? mg is passing through the axis. So the force passes through the axis, its torque is what? Zero. This ball on its own cannot start any type of rotation. Why? Because mg passes through the center. तो अगर टॉर्क नहीं है और फोर्स नहीं है तो ना तो स्पीड चेंज होगी और ना ही इसका क्या चेंज होगा ओमेगा. Which means what? If you can create a perfect setup, if you can create a track which is perfectly flat, horizontal, and you place a wheel on top of it in pure rolling mode, if you release it, it will keep on moving forever. Listen again, it is not going to stop. एक बार चला तो वो हमेशा क्या करेगा? चलता रहेगा. Provided you have a perfect round shape wheel which you place on a perfect horizontal surface. It should be a perfect horizontal surface. शायद आपने इस तरह की चीज कभी सुनी हो, देखी हो या नोटिस की हो. लोग रेलवे ट्रैक्स को जो लोग रिपेयर करते हैं, they have a trolley sort of thing without any engine. कुछ लोग थोड़ी देर के लिए उस ट्रॉली को पुश करते हैं and then they jump into it. It keeps on rolling, moving for about 2-3 kilometers, provided speed sufficient इसको मिल गई है. Now, why did I give you the example of this trolley and railway track? The wheels, they are of steel, track is also of steel, and therefore less deformation is present. Things are almost perfect, not perfect, almost, and therefore we can expect that friction is almost negligible. इस वजह से वो ट्रॉली बहुत दूर तक मूव करते चले जाती है. If somehow we can produce, which we can never, if we somehow can produce a perfect round shape and a perfect horizontal track, तो ये ट्रॉली एक बार इसको मोशन वेलोसिटी दे दी, उसके बाद उसको दोबारा आपको स्पीड देने की जरूरत नहीं है. विदाउट एनी फ्यूल, विदाउट एनीथिंग, इट विल कीप ऑन मूविंग, which is what? A completely theoretical thing, provided things are flat and completely round. In real life, if you look at the tire, आपकी बाइक का टायर हो या कार के टायर हो, तो जैसे ही ग्राउंड पर आता है तो आपने देखा होगा कि टायर यहाँ पर फ्लैट हो जाता है because of the pressure and all. So it loses its roundness, and therefore in that situation this concept is not valid as it is, with certain modification. Now when I say a perfect round shape, it means there will be a single contact point. लेकिन अगर आप कार के टायर की बात करें या बाइक के टायर की बात करें तो वो फ्लैट होने की वजह से there are several contact points. Since there are several contact points, normal reaction हमारा जरूरी नहीं सेंटर से पास हो, एक्सिस से, तो वहां पर सिचुएशन इस तरह की बन जाती है कि आप प्योर रोलिंग मोड में अगर रिलीज करोगे भी तो कुछ देर के बाद वो क्या हो जाएगा? अपने आप रुक जाएगा. अगर आप एक ऐसी बाइक बना पाते और एक ऐसी रोड जहां पर परफेक्शन है, तो आपने क्या किया? आपने एक बार बाइक को स्पीड दी, आप उस पर बैठ गए, and then it will keep on moving forever. You can start your journey from Kashmir and you can go to Kanyakumari without ever using any petrol pump and all. That's true if you can, but you cannot because of these deformations. So, लेकिन ये रोलिंग का कॉन्सेप्ट हमारे लिए कितना हेल्पफुल है, किस तरह की चीजें ये जनरेट करता है हमारे लिए, उसको अगले कुछ एग्जाम्पल से आप थोड़ा और अच्छे से फील कर पाओगे. देखते जाना. ये फ्रिक्शन के डायरेक्शन एंड ऑल, ये सारी चीजें इस नेक्स्ट पार्ट से और ज्यादा इजी फील होगा आपको. This is your bicycle. A simple bicycle, and somebody's sitting over here and paddling the whole thing. The bicycle has to move in this direction. This is the rear wheel, and initially bicycle is at rest and you start pedaling and then it moves in the forward direction. This is the forward direction. Forward wheel, rear wheel, and it's a rear wheel drive, it's your bicycle. The moment you start paddling this thing, what I'm saying is you start increasing velocity of the bicycle. We are trying to increase V. इतनी चीज क्लियर है कि अगर आप V बढ़ाना चाहते हो तो इसका ओमेगा V बढ़ेगा. इट्स अ रियल लाइफ सिचुएशन कि आपके पास बाइक है, आपने पैडलिंग शुरू की, बाइक इसका V भी डेवलप होता है और व्हील्स के पास क्या डेवलप होता है, ओमेगा. So this bike is moving in this direction with V, and wheels are rotating like this. When I say V, remember the axle, which is the center of mass. The center of mass is moving with V, center of mass is moving with V, and wheels are rotating with omega. This is also moving with same V. And remember the scenario, we are paddling so that V increases. Both surfaces are rough and mode of rolling is pure rolling. At no point, contact point of the wheel is going to slip. Everything is always in pure rolling mode. So my question is, this is pure rolling on the horizontal surface and you have to increase V and omega. Is friction present at these contact points? First of all, yes or no? What do you think? What is your thinking? Is friction present between the wheels and the rough horizontal road? Good. Friction is present. Now, who will tell me what is the direction of this friction? Is direction of friction same for both wheels? If you think it is same for both wheels, then write down that direction, forward or backward in that sense. If you think that direction of friction will be different for different wheels, then mention it accordingly. Good. One of you has answered correctly. Now, look here. You'll be able to feel everything. पूरी कहानी को सिंपल लैंग्वेज में समझना. आप इस साइकिल पर बैठते हो. इनिशियली इसकी वेलोसिटी 0 है. U is 0. You start paddling and then it gains what? Speed, and you also increase angular velocity. Now tell me, what is that which increases angular velocity of the rear wheel? What is that which is producing rotational motion? Paddling or friction at the contact point? What is the cause of rotation of the rear wheel? Paddling or the friction? If you think paddling, then write down paddling. If you think friction, then write down friction. And I'm asking this thing for the rear wheel. Good. Initially, bicycle is at rest. If you are not paddling at all, then this bike is not going to move. So what started rotational motion in the wheel? Paddling, which produces what? Omega. Now what happens? The moment you start paddling, this is something like this. This is the wheel. This is the wheel. And जो paddling वाला काम है वो मेरे हाथ करेंगे यहाँ पर. This is the effect of paddling. Look at the contact point. हमने क्या किया? थोड़ी देर के लिए इस बाइक को, इस rear wheel को ग्राउंड से ऊपर लिफ्ट कर दिया. That's how you will be able to visualize this thing. And you can try this thing with your bicycle also. आपने इस rear wheel को ग्राउंड से थोड़ी देर के लिए उठाया and start paddling. What happens? This happens. This wheel starts rotating only. Look at this point which is going to be in contact with the ground. इसकी टेंडेंसी देखना. ये जो पॉइंट है, इसकी टेंडेंसी कहाँ है जाने की? Backwards. So the moment you place the wheel on the ground, due to paddling, this contact point is trying to move backwards, and friction, it does what? It opposes relative motion of two surfaces which are in contact. So the moment paddling creates rotational motion, this contact point starts moving in the backward direction, and to oppose this backward motion, friction acts in the forward direction. And the moment friction acts in the forward direction, this is the direction of friction. What it does, this force which is present on the rear wheel is going to increase its velocity. अभी खत्म नहीं हुआ. ये जो FR है, let's call it FR1, which is acting on this rear wheel. Now, what about torque of friction? This torque of friction is like this. This is the torque of friction. Let's call it tau 1. Tau 1 is what? Torque of friction 1. अब just imagine this thing. आपने rear wheel को lift किया हुआ था and you are simply paddling और ये चीज क्या कर रही थी? Rotate. The moment you bring it down, this contact point comes in contact with the ground. Immediately what happens? This torque is going to oppose efforts. Your efforts. Your efforts are in the clockwise direction. A bike moving in the forward direction means you have to paddle clockwise. This clockwise paddling is being opposed by the torque of friction. इसीलिए अगर आपने एक स्टैंड पर बाइसिकल को खड़ा किया हुआ है, आपने किसी से बोला कि इसको उठा के रखें, and then you are paddling the whole thing, and immediately when he drops it, the person who is holding the bicycle, when he drops it, you find what? You find it difficult to paddle. So what is that which is opposing your paddling efforts? This torque of friction. Tell me, for rear wheel, are you comfortable with the direction of Fr and direction of torque, and can you feel that this torque of friction is going to oppose your efforts? If you are comfortable with this part for the rear wheel, then write down yes in the comment box fast. One of you is saying that, but you said friction between contact point and surface is zero. I said friction between contact point and surface is zero, but go and read the statement. In the absence of other forces, the person who is sitting on the bicycle, his efforts, they are an external efforts, and therefore this is not that pure rolling. इसके अंदर उस प्योर रोलिंग पर भी आएंगे जहां पर फ्रिक्शन जीरो था, लेकिन अभी हमारी शुरुआत कहां से हुई है? इनिशियल वेलोसिटी इज व्हाट? जीरो, एंड यू स्टार्ट पैडलिंग. वो जो केस है प्योर रोलिंग वाला, उस पर भी पहुंचेंगे, आएगी चीज क्लियर होगी आपको. जस्ट होल्ड ऑन. नाउ अब हमारी बाइसिकल रेस्ट पर थी, हमने पैडलिंग की, रियर व्हील रोटेट करना शुरू कर रहा है एंड फ्रिक्शन इज अपोजिंग इट. नाउ टेल मी, व्हाट इज दैट व्हिच इंक्रीजेस, व्हाट इज दैट व्हिच इज गोइंग टू इंक्रीज एंगुलर वेलोसिटी ऑफ द फ्रंट व्हील? दिस फ्रंट व्हील, व्हाट इज द mechanism which is going to increase its omega of the front wheel? What do you think? Can you answer this part? Let me ask you again. Is this paddling going to increase angular velocity of the front wheel? Let me answer this. No, it cannot. Why? Because the chain is connected to the rear wheel. So your paddling efforts, they are increasing angular velocity of the rear wheel only. The whole structure of the bicycle is connected to this wheel at the axle. So all the forces coming from the skeleton, the structure of the bicycle, all those forces are acting at the axle, that is the axis, and therefore they cannot produce any torque. So what is that which produces this omega? That can only be friction between the wheel and the ground. Now what direction this friction has? If you say that friction is acting in this forward direction, if somebody says, then there is a problem. ये जो फ्रिक्शन है इसका टॉर्क कैसा आता? एंटी. लेकिन जब आप पैडलिंग करोगे तो ये व्हील भी क्या रोटेट करेगा? क्लॉक. So what is that which has produced this clockwise rotation? This clockwise rotation can only be produced by force of friction which is acting backwards. Let's call it Fr2. So on the front wheel, on this front wheel, friction acts like this, and this produces a torque. Let's call it Fr2. Because of this Fr2, wheel starts rotating clockwise. Now, what I was telling you is that the rotational motion in the front wheel cannot be produced by the pedaling efforts or by the structure of the bicycle. It is being produced by the friction between the wheel and the ground, which is acting in the backward direction, producing a clockwise torque, thereby producing clockwise angular velocity. Again, कितना easy है इस चीज को विजुलाइज करना. आपने क्या किया, आपने इस rear wheel को lift किया and you rotated the whole thing. Does this wheel rotate? No. Why? Because your efforts are producing angular velocity in the rear wheel only. Now when you put it down, when you place this wheel on the ground, immediately FR1 acts in the forward direction. Because of this FR1, you feel a force in the forward direction, and the moment this force is present in the forward direction, the forward direction force, it acts on the bicycle, it starts moving in the forward direction. Now what happens? Imagine this part. This is your front wheel now. Due to the pedaling effect, bicycle starts moving in the forward direction. Look what happens to the front wheel. It has no rotation, but somebody has pushed the whole thing in the forward direction. Imagine this. You have a wheel which is being pushed. The moment you push it, what happens? Look at this contact point. This contact point, I hope you can see, is slipping against my hand in the forward direction. If this contact point has a tendency to move forward, then friction is going to oppose it. And how does it oppose it? It is going to oppose this forward motion by acting in the backward direction, which is the FR2. And the moment FR2 acts in the backward direction, it produces what? A clockwise torque, which develops omega in the front wheel. आपने इस wheel को लिया. If I push the wheel in the forward direction, if I push this wheel in the forward direction, you can do it yourself. Take a wheel or anything, hold it peacefully, and then you try to move it forward. If you try to move it forward, it will develop this omega because of friction. But now my question was, which one is the larger force, FR1 or FR2? There are two forces, FR1 acting in the forward direction, FR2 acting in the backward direction. If they both are equal, then they will cancel each other and cycle is not going to move at all because there will be no horizontal force. If FR2 is the dominating force, then net force will act in the backward direction. तो फिर से एक strange behavior कि हमने पैडलिंग की और साइकिल आगे जाने की जगह कहां जाने लगी, पीछे. But does it happen? No. So what will happen? The moment you start pedaling, these forces are going to act and FR1 will be greater than FR2. Suppose this is 10, this is 8. So what is net force? 10 minus 8, which is what? 2. Because of that force of 2, this bicycle is going to move in this direction. On the bicycle, you have a net force in this direction, which will increase what? V. What is going to increase omega of the rear wheel? Your pedaling efforts. What is going to increase omega of the front wheel? Friction 2. Now, जो कुछ लोगों ने पूछा था कि सर आपने बोला था प्योर रोलिंग में तो फ्रिक्शन 0 होता है. अब once you developed some V and omega, you stop pedaling the bicycle. The moment you stop it, now is the situation which was explained in the previous part. Your bicycle is not being powered now. If it is not being powered, whatever V you have got and whatever omega you have got, and assuming everything is perfect, if you stop paddling, this bicycle will keep on moving forever with that particular V. फिर से U0 था, हमने पैडलिंग शुरू की, थोड़ी देर बाद जाकर हमारा V हो गया 10, सपोज अकॉर्डिंगली कुछ ओमेगा भी बन गया, प्योर रोलिंग है तो V इक्वल्स टू R ओमेगा. फ्रॉम 0 to 10 ये जो इंक्रीज है वो कब आएगा? If you keep on paddling. The moment you stop paddling, surface is horizontal, things are round, अब आपको पैडलिंग की जरूरत नहीं है. This bicycle will keep on moving. और आपने देखा है कि हमारी साइकिल हमेशा तो नहीं लेकिन बहुत देर तक अगर सरफेस ठीक ठाक है तो चलती रहती है. अब टायर्स अगेन there are deformations at both places and therefore not everything is happening accordingly. इसलिए कुछ ना कुछ देर के बाद after around 100 meter 500 meter depending on the speed which you gave it is going to come at rest. But if you talk about ideal situations, stop paddling and the bicycle is in what? Pure rolling mode. Which pure rolling mode? When there are no external efforts present on the wheel, on the bicycle. In that case, friction will become what? 0. This is pure rolling in the presence of what? External efforts which are coming from the person who is sitting on the bicycle. Do you understand this motion of bicycle, yes or no? And even if you have small doubt in this part, just don't worry. Everything will be clear once we consider the next setup. But first write down these statements. When a bicycle is at rest, and is accelerated in the forward direction, inside the bracket due to paddling. Angular velocity of the rear wheel increases due to the torque produced by paddling. Whereas angular speed of the front wheel increases because of friction between front wheel and ground or the road. After the bicycle gains some speed and paddling is stopped. After the bicycle gains some speed, paddling is stopped. Now, there will be no friction between both wheels and the ground. There will be no friction between both wheels and the ground. So, this is the starting stage. You're accelerating your bike. What is the intermediate stage? You have stopped paddling and the bike is running. Now let's come to the final stage. You want to stop your bicycle. Let's discuss this final stage and then we'll complete the sentence and all. Or you can just terminate the sentence right here and let's discuss the stopping motion. Now, initial part, this is your intermediate part. You can draw a separate figure, just a small one, draw the bicycle, and right now this is the intermediate part. In this intermediate part, no paddling is present. We're not paddling this bicycle, and therefore FR1 is 0, FR2 is also 0. You can draw a neat and clean figure, but for us this is sufficient. Intermediate situation, we have stopped paddling. No friction is present between this wheel and ground, between this wheel and the ground, which is what that pure rolling statement, that in the absence of external forces, pure rolling on the horizontal surface, no friction is present. That's the situation. Now let's discuss the final situation. Final situation, which is the final stopping part. We have stopped paddling and we are applying brakes. That's how you stop it. And let's say that brakes are only present for the rear wheels. Let's discuss this part, which is always a good thing also. I hope you remember, we normally do not apply brakes for the front wheel because it creates an extra angular momentum and the whole thing will jump and will create a good harm. So, brakes are being applied to stop the bicycle and brakes are only present in the rear wheel. Let me first gather an idea from you. What do you think will be the directions of FR1 and FR2? You have to answer like this. FR1, FR2, you can say 1 and 2 only. 1 means it will be FR1, 2 means it will be FR2. If you think that 1 is in forward direction, then write down 1 forward. If you think 2 is also in the forward direction, 2 forward, in short FWD. If you think they are in the backward direction, then write down accordingly. So what do you think when you stop the bicycle by using brakes? What happens to FR1 and FR2? Remember, we have stopped paddling and we are applying brakes, and brakes are present only in the rear wheel. Think about it. किस तरह से रोटेशनल केस स्पीड इन चीजों को आप कम कर सकते हो, ये सोचने की कोशिश करो। Look here. Let's draw a neat and clean figure. Well, let's start with the front wheel. Why? Because for the rear wheel there are two things. For the rear wheel there are two things which are providing torque: brakes as well as friction between the tires and road. Whereas for the front wheel there is only friction present, and therefore it will be easier for us to understand direction of friction for the front wheel, and that will immediately give us the direction of friction on the rear wheel also. These are the wheels, your bicycle. This is moving in this direction with V. This is rotating with omega. And when you apply brakes, this omega is going to decrease. Omega for rear wheel as well as for the front wheel, it's going to decrease. And of course, V is also going to decrease. If I say that friction is still acting in the backward direction, तो प्रॉब्लम है क्या? इस एफआर का टॉर्क अभी भी कैसा है? क्लॉक. So if you are applying brakes, this wheel has to stop. It has to lose its angular speed. If friction is still acting in the backward direction, then it is continuously increasing omega. Possible नहीं है. इसने रुकना है, इसकी स्पीड कम होनी है. So if this wheel has to lose its angular velocity, then friction cannot act in the backward direction. It has to act like this. This is the direction of FR2. This FR2 will produce a torque in anti-clockwise sense, which is going to oppose omega. Look at the sense of omega being opposed by the torque of FR2. Now, एक बार अपने को फ्रंट व्हील की कहानी क्लियर है तो जो अपना रियर व्हील है ये ऑटोमेटिकली चीजें इसके लिए क्लियर हो जाएंगी। कैसे? सपोज आपने बोला कि इस रियर व्हील पर फ्रिक्शन आगे लग रहा है। I hope you can see the problem with the figure, with the setup. You have a bicycle which is being pushed by two forces acting in the same direction, acting in the forward direction. This and this, if they both are acting in the forward direction, then you cannot decrease speed of the bicycle. अगर आप इसकी स्पीड कम करना चाहते हो तो फिर अब इस FR1 को कहां लगना होगा? पीछे की तरफ। And that's how it acts. That's how it acts. FR1 is acting in the backward direction, FR2 is acting in the forward direction, and again FR1 is the dominating one. ये ज्यादा है, ये कम है. This is 10, this is 8. What is that force? 10 minus 8, which is what? 2. इस पूरी बॉडी पर एक फोर्स लग रहा है पीछे की तरफ. बॉडी जा कहाँ रही है? आगे की तरफ. इसकी स्पीड लगातार क्या होगी? डिक्रीज. तो एक बार जैसे हमने फ्रंट व्हील को इन्वेस्टिगेट किया, फ्रंट व्हील को इन्वेस्टिगेट करना बड़ा आसान था. क्यों था? इसका रोटेशनल पार्ट कम और ज्यादा करने का काम किसका था? फ्रिक्शन का. ब्रेक्स लगाया है अपन ने, ओमेगा क्या होगा? डिक्रीज. And therefore FR2 can only act in the forward direction. If FR1 also acts in the forward direction, then the bicycle is being pushed forward. You cannot decrease its speed. But you know that when you apply brakes, this bicycle is going to stop. So to decrease speed of the bicycle, FR1 should act in the backward direction. Now what happened with the brakes? Look at that part. Suppose these are the brakes. Somehow, just imagine you basically press these two boxes and this stops what wheel? Just imagine this type of thing. And you apply brakes, basically stopping, pressing these two things against the rim, and that is causing it to lose its rotational speed. So, this wheel is moving in this direction with omega, and you want to decrease omega. चाहे फ्रंट हो चाहे रियल, दोनों का ओमेगा क्या होने वाला है? डिक्रीज. ये जो ओमेगा डिक्रीज करने का काम है, आपको दिख रहा है कि FR1 के हाथ में नहीं है. FR1 in this case is trying to support this omega. Look at the sense of rotation. This is the torque of FR1, which is basically increasing omega, trying to increase. And therefore, you need to press these brakes hard. These brakes, they produce a backward torque like this. This torque, which you see in the blue, is the torque produced by the braking action. This torque opposes omega, and therefore this rear wheel stops. FR1 is trying to help this thing. इसलिए आपने इसको इतना हार्ड पुश किया हुआ है कि आप इस चीज को क्या कर सकें? रोक सकें. And finally, your bicycle comes to rest. And then you can repeat the whole process again. If you have to start increasing its speed, pedal again, that will be the starting position. Intermediate position, do not pedal at all. Final position is in front of you. Are you comfortable with this stopping part? Yes or no? And this is a very good example of rolling. To understand rolling, the Bicycle part is something where you can easily feel all the things. Now, let's understand this whole part again with the help of a simple 5 rupee coin or 1 rupee coin, which you can easily carry out this kind of experiment with a simple 1 rupee coin. Look at this. And try to answer this part. How easy everything is will be clear in this figure. This is horizontal surface. Remember, it is rough. You have a coin. This is a coin. And what you did, you produce an omega only. It doesn't have any initial speed. Center of mass is not moving, it is only having what? Rotational speed. So what I expect from you is that hold a coin and give it what? Rotation, and then put it on the ground. So what I'm expecting from you is that you create rotation in the coin, and then when you place it over the rough horizontal surface, answer this part. In which direction this coin is going to go? Forward direction or in the backward direction? Answer this part first. Where is it going to go? Once you place this coin over the rough surface, where will it move? Good. It is going to move in the forward direction. So the moment you place it, it has no initial speed. You put it on the ground. Let's say it gained a speed of 2 meters per second. I've taken some values so that न्यूमेरिकली इजी रहेगा आपके लिए समझना. Say omega was some 10 radians per second, and initially this coin has no speed. It is above the ground. This is the coin, you gave it rotational motion 10 radians per second, it has no initial speed. You put it on the ground, and immediately you put it on the ground, you know this thing. आपने किया होगा अपनी लाइफ में कभी ना कभी. Rotate, release, rotate, release. And the coin is going to move in the forward direction. Let's say it develops a speed of 2 meters per second. What do you think omega will be? Tell me this. Omega initially was 10. What is your opinion? This omega will be 8, will remain 10, or will be 12? ये फीलिंग डेवलप हो गया आपके पास. इनिशियली ओमेगा क्या था 10, यू क्या था 0, ग्राउंड पे रखा, स्पीड बढ़कर 2 हो गई. What I'm asking you is omega from 10 will remain 10 or decreases to 8 or it increases and becomes 12. What do you think? What do you think omega will become? 8, 10 or 12? नो रिस्पॉन्स। कोई नहीं, देखना हमने क्या किया था, हमने इस व्हील के अंदर केवल क्या प्रोड्यूस किया था, रोटेशन। लुक एट दिस रोटेशन, दिस कांटेक्ट पॉइंट just before it comes in contact, look at the contact point, just before it comes in contact it is moving backwards against the ground. So as it moves backwards against the ground, ground is going to oppose the backward motion. And how do you oppose that? By applying a force in this direction, which is the force of friction. जैसे ही ये कॉइन ग्राउंड के टच में आएगा, this point due to rotation was going back. To oppose this backward motion, friction acts in the forward direction. ये जो फोर्स है कहां लगा, आगे। इसी ने क्या डेवलप किया, 0u को क्या बना दिया, 2। अब लेकिन ये फोर्स अगर आगे लगा है तो इसका टॉर्क इधर होगा, बट दिस टॉर्क इज अपोजिंग ओमेगा। ओमेगा इज क्लॉक, टॉर्क इज एंटी, and therefore 8 is not, 10 is not possible, 12 is not possible. What is the correct thing? 8. The moment you place it on the ground, जो कॉइन है आपका, उसकी रोटेशनल स्पीड क्या हो जाएगी, डिक्रीज। रोटेशनल काइनेटिक एनर्जी क्या हो जाएगी, डिक्रीज। ट्रांसलेटरी काइनेटिक एनर्जी क्या हो जाएगी, इंक्रीज। इसका जो नेक्स्ट केस है, we'll discuss that in the next class, and that will be this thing. You have a wheel and we gave it u. We did not give it any omega. We gave it u. It has no omega. You can do this experiment yourself. Take the same coin. Do not produce any rotation. Just throw it on the ground. Once you throw it and it comes in contact with the ground, try to visualize what happens with omega, what happens with u, what happens with direction of friction. If you can do that, you will understand everything in the next class also. Put on this much and then you can leave. Thank you very much.